What is going on, guys? My name is Amos and I'm back again with another video. So in today's video, we're going to begin our discussion on sets or les ensembles. So basically, we are going to be diving into the fascinating world of sets. Now, sets are a fundamental concept in mathematics that are going to lay the groundwork for a variety of topics. Now, whether you are new to the idea or looking to refresh your understanding, let's embark on this journey of discovery together. All right. So, what is a set? What is a set? Now, a set is going to be a collection of objects that are related to each other in some way. So, for example, we can have a set of apples, a set of boxes, a set of numbers. Now, one thing that you mustn't do, what you guys must not do, is to suppose that a set is just going to be a collection of numbers. Well, the elements of a set are not always numbers. So we are talking about objects. Now, object is a good word to use if we want to talk about the contents of a particular set. Now, right, so a set is a collection. A set is a collection. It is a collection of the same entity of objects. Is a collection of the same entity of objects. Entity of objects. Now, this is what a set is going to be. This is what a set is going to be. Now, it is common to denote sets with capital letters. So we basically use capital letters to denote sets, and whenever we want to talk about an element of a set, we'll be using something that is more generic, like an X, for example, small letter X, to represent every element of that set. Now, you guys have already looked at, well, we've already done chapter 1, where we talked about mathematical logic or propositional logic. Now, I believe you guys have watched the videos and have gotten some of the important concepts. So whenever X is an element of it, let's say we have a set, let E be a set. Now, let E be a set. So let E be a set. So whenever an element X is in the set E, we use this symbol to mean that X is in the set E. So this is going to mean that X is an element in the set E. Now, this is going to be only, so this is going to be read as X appartient à E. So X appartient à E. Appartient à E. Meaning X is going to be an element of the set E. Now, whenever X is not an element of the set E, then we're going to use this symbol. So basically, we have a diagonal bar over the symbol of over this symbol, which means X is an element of A. So basically, this is what we write. So this is when X is not an element of the set E. Only X n'appartient pas à E. X n'appartient pas à E. So this is how we read this. So you're going to hear a lot of this when you guys come for your lessons. Now, whenever two elements of a set are equal, whenever X and Y are elements of the set E, and the two quantities are equal, so we're going to say, so quel que soit X dans X et Y dans. So whenever we have two so now I've written E squared to signify that I'm getting a couple from the set E. So both X and Y are elements of the set E. Now we are going to look at what is known as the Cartesian product, and you guys are going to have a better understanding of what I've written here. But what this means is that X and Y are both elements of the set E. So whenever X is equal to E, we are going to say X is equal to E, and we're going to use this symbol. So you read it as X est égal à Y. So whenever X is not equal to Y, then we're going to write something like this. So X is not equal to Y. All right. So this is your introduction. So now, whenever we are talking about sets, one other important piece of information you guys shouldn't forget, or one piece of information you guys should always remember, is that the order in a set does not matter. So the order does not matter. So for example, somebody can say, I have a set A of elements A, B, C, D, and E. Well, another person might also say, all right, I have the same set. but the order of the elements is different. Now, whenever we're talking about sets, this set is also going to be equal to this set, to the set B, E, C, A, and D. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So we basically have the same elements, but the order is not the same. Now, regardless of whether the order is the same or not, well, the sets are actually going to be equal. And sometimes the repetitions are also not very important when it comes to sets. The repetitions are also not very important. So now there are two ways of writing sets. Now, one of the ways in which a set can be written is known as en extension. So this is going to be the first, I'm sure, a set written in extension, en extension. So this is basically when you just list out all the elements of the set A, for example. So you have A, B, C, D, E, and F. You just list out all the elements of the set A. The second way in which sets are going to be written or represented is going to be en compréhension. So en compréhension. Now this is going to be, this is similar to what you guys did in your senior secondary school or your junior secondary school when you looked at set builder notation. So for example, if I have a set, now let me just give you guys one very simple set so that we actually make sense of what we are trying to do. So let A be the set of numbers 0 through 9. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Great. So now if you look at this set, now what property are all these, what property is being satisfied by all the elements of this set? So that is one thing. First of all, you have to, if you want to write a set en compréhension, you have to first of all look at a property that is, or that all the elements of the set are going to what? Are going to satisfy. Now, looking at these numbers, I can easily tell that these are natural numbers. All right, these are natural numbers, and these natural numbers are between 0 and 9. All right, so X is going to be a generic element, so it is going to represent any element in the set A. So all the numbers are going to be between 0 and 9. All right, so en compréhension, this set A is going to be equal to the set of all elements X in the set of natural numbers. Now this is going to be very, very important. All these numbers that we have are natural numbers, such that X is going to be between 0 and 9. Now this is a very concise way of writing the elements of a set, as you do not have to write explicitly the elements that are in the set A. So this is going to be your shorter version. So this is what is known as en compréhension. That's also another way of writing the set. Another way is graphically showing what the set is going to contain. So this is going to be achieved by using what is known as le diagramme de Venn, or the Venn diagram. So for example, I can say, okay, my set A was a set of elements, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you guys, I'm sure you get the information. So this is what is known as le diagramme de Venn, le diagramme de Venn. So this is going to be the diagram de Venn. So this is going to graphically represent our sets. All right, now that being said, let's talk about something that is a little bit more interesting, or maybe something that is a little bit new to you guys. All right, so it is the idea of finite and infinite sets. All right, so we have what we call finite and infinite sets. So whenever you guys can count the number of elements a set has, well, that set is going to be classified as a finite set. Now, whenever you guys cannot count the number of elements in that particular set, well, that set is going to be an infinite set. Now, I can give you guys examples of finite and infinite sets. All right, now let me give you guys an example of a finite set. So the set A that we are from writing of numbers of all elements X in the set of integers, I mean the set of natural numbers, sorry, such that X is going to be between, all right, such that X is going to be between 0 and 9, such that X is going to be between 0 and 9. So we basically looked at the set A. All right, now this set A, we are able to count the number of elements that the set A has. So because we're able to count the number of elements that the set A has, well, the set A is going to be known as a finite set. An example of an infinite set is the set of real numbers. So what is this set of real numbers? Well, the set of real numbers is going to be the set of positive and negative integers. We're also going to throw in the rational numbers as well as the irrational numbers. All right. Now, 0, I'm going to like consider 0 as my middle point, and from 0 I can have my positive numbers again between 1 and 2. Between 1 and 2, we also have infinitely many numbers here. For example, I have 1.2. Another person, okay, I have 1.35. Another one can say, okay, I have 1.75, 6, 9, 8, 2, 3, and so on and so forth. So you basically have infinitely many numbers between 1 and 2 as well. And then, so 1 and 2, 1 and 2 is also, the interval 1 and 2 might also be considered as something that is of infinite in nature. All right, so whenever we're talking about these guys, so basically we're talking about a set of real numbers. So you have these elements. All right, so you have your 3 here, you have your 4, and you can basically go on and on until you reach what is known as infinity. Now, infinity is not a number, it is a concept that is used to describe something that is incomprehensively large, or something that is extremely big, such that, all right, it is going to be very difficult to actually have that particular thing as a number. All right, so here you have your negative numbers, and once more between -1 and -2 you have infinitely many numbers again, and then you keep on going, and hopefully you guys get the point. So this is going to be an example of an infinite set. So you have your 2 examples of finite and infinite sets. So whenever we have a finite set, we are going to also talk about something that is also interesting when it comes to finite sets. We can talk about the idea of cardinality. Now, this cardinality, the word cardinality is going to mean the number of elements a particular set has. So the cardinality of the set A, for example, is the number of elements that are in the set A. Cardinality, le cardinal. So cardinality, all right. So this is going to be the number of elements in a particular set. So for example, if I want to find the number of elements in the set A, I'm going to say, what is the card of the set A? Well, the card of the set A, now I'll write the set A again. Well, A is a set of the elements x in the set of natural numbers, such that the x is going to be between 0 and 9. Now, if you are going to write this set in on extension, you're going to find out that the cardinality of the set A is going to be equal to 10. Now, by convention, I'm going to write this here. By convention, we have what is known as an empty set. All right, now an empty set is a set with no members, or a set with no elements. Then the cardinality, and then we denote the empty set by that symbol, or the cardinality of the empty set is by convention 0, or the cardinality of the empty set is 0, because the empty set does not have members. And then we also have what is known as a singleton set, or a singleton set is basically going to have now let me just write that properly. So a singleton set is going to be a set with only one element. For example, the set that only has an A here, a set that only has a 1 here, maybe the set that only has one object, let's say. So the cardinality of this singleton set is going to be 1. So it's going to be the card of, for example, the set 1. This is going to be equal to 1. All right. Thank you guys for watching, and I'll see you in the next video.